Hello my friends and welcome to FISHTORY. I'm Alexander Williamson, your guide to today's episode on fascinating fish discoveries that have happened in the last week in academia. Now, there are 3 different journals that have published 3 different articles that are all related in a really fascinating way. So today we are going to be unpacking those and talking about some interesting discoveries. First of all, Danios, zebrafish as they're commonly known. It turns out that 1 fish makes some noise, right? You'd expect that. 2 fish makes a little more noise. Well, 3 fish makes as much noise as 2 fish. And 5 fish makes as much noise as 1 fish? So it turns out that having 1 fish or 2 fish is noisier than having 40 or 50 in a school. How is this possible? And it turns out that thanks to some research done recently in the lab, they have figured out the physics behind the acoustical mystery that is schooling fish and how it helps them both be silent to predators, or prey for that matter, and how it helps them swim more efficiently. So, we'll talk about that. Then the next paper is what defines a school of fish anyhow? Well, it turns out it's not just some nebulous term that we throw around. It's actually a very specific type of behavior. There are singular fish moving as individuals. There are shoals that are spread out a little loosely, but they're still communicating and paying attention to one another. And then there are schools that almost behave as one moving organism. And something occurs, something clicks and changes, both chemically, biologically, and behaviorally in the fish for this to occur. They have unlocked what that is and the secret of it all. So we're going to talk about that for a moment before we bring it all home with the most fascinating topic, which is mormyrids, or elephant-nosed fish, and their ability to use electromagnetic fields and electrical impulses that they create in their body to map the world around them and to communicate with other mormyrids. Now, we knew that they had a language of at least 30 words or so. And that's fascinating enough. However, now we are unlocking networking as creatures like we would use cell towers in a modern day electrical grid, and they are 3 times more efficient when they are networked and using their electromagnetism than when they are alone. So we'll talk about it, we'll look at some illustrations, and we'll have a lot of fun untangling all this new science right now. In this study, the fascinating thing we found out was that fish that are alone are louder and more obvious to predatory fish. That's what this guy is from a side view. This is a top view. Sorry if that's confusing. And then this is a school from a top view. So while 1 fish moving through the water alone is pushing off the water, moving forward, going over rocks and whatever other imagery and things are in the way, all of its movements create waves of sound and pressure. And on a fish, you've got all sorts of sensory organs. So you've got the lateral line that runs down the side of the fish and senses pressure and or pressure waves. And sound is really just pressure waves anyway. But they have usually an ear that senses things in the water and an ear that senses things through their swim bladder, which is filled with atmospheric gases. And then they have also all these little cells on their body, some more than others depending on the species and how they've evolved. And those sense pressure and temperature and things like that, sunlight even, like the warmth of it. And then they've got, obviously, their eyes. Now, predatory fish tend to have eyes with binocular vision. So they tend to have eyes like humans that are set forward so that both eyes look forward and they scan by turning their head more so. Whereas little fish, little things like neon tetras and things that are not predatory fish, they tend to have eyes that are more set on the side of their body. That's just a general rule of evolution, out of water or in the water. But it's something that comes in handy because these little fish that have eyes on the side of their head that can't see forward as easily, they can actually form up into schools and behave like a singular giant fish. Here you've still got this turbulent flow that goes on behind like where the tail of an individual fish is. And you've got the whole group moving and individuals breaking way essentially for the whole group at a point or as kind of a spear point almost. And they cut through the water, and then the group tends to be kind of V-shaped, and then it creates these waves in the water that spread out the water, and as they come back into the area of low pressure that's created by the fish swimming through it, that then pushes them forward, just like the fish swimming. So it actually conserves energy for the fish to do this. But for safety's sense, this big predatory fish wants a meal. Oftentimes they'll have extra organs like odontodes or whiskers. They'll have taste buds all over their body. It's incredible what fish are able to sense. And I've got a lot of videos on details of that. But it turns out that the noise that this fish makes alone, that alerts this big predatory fish to dinner time, that it is far, far louder or more noticeable to this fish downstream than this whole group that could be dozens and dozens of fish. And that doesn't seem possible, does it? But there is a peculiarity in physics and acoustics, and that is noise cancellation. So if you've got sound, it looks like a wave, right? Pardon. It looks like a wave. And sound really just is moving air or water or whatever media it's moving through and vibrating it, and then it's interpreted by wherever it ends up, our ear or a fish's ear or its lateral line. Those waves are interpreted by how far apart they are and how tall they are, which altogether tells how much energy they had. And we sense that as either, pressure waves if it's really, really deep and full of energy, or high frequency we sense as loud, high-pitched noises that are coming in very quickly. Now, fish do the same thing, and they can sense with multiple parts of their body, but in the water you've got just all sorts of currents and splashing and things that just move and make all sorts of differential pressure zones. And scientists figured out in the 1940s that sound could be canceled out. So sound is a wave, but if you have a sound wave, this blue wave, if you can exactly match up with it the opposite frequencies with another source of energy or sound, it cancels it out because the average is 0 here rather than having peaks and valleys or distance and energy. It just comes out as blank. It's too much information and it cancels itself out as far as being interpreted by the human ear or by the animal ear. So one or two fish moving alone make a little bit of a commotion, and there are 2 points where they're making a commotion. Fish in a school hang out so tightly when they're truly schooling that they actually are making less of that sound because their tails in particular are moving left to right, left to right. And when they watch them in slow motion in the laboratory, it turns out that for every fish moving its tail to the left 1 second, there was another one moving their tail to the right that second. So altogether, the water pressure and the sound being put off was being canceled out by the vast majority of fish. And they literally do it 1 for 1. So I mean, it is very, very accurate that they'll all be doing it. They have evolved to know that if the fish next to you's tail is to the left right now, yours needs to be to the right. And amazingly, it doesn't impact this their hydrodynamics because they are moving as a big group. So the fish will actually hear about the same amount of noise from one fish as from 50 fish, and it will think it's just one big fish, which it's far less likely to attack than if it's one or possibly even 2 fish. Then it's hearing splish splash times 2, and it's a big problem. But if the school breaks up all of a sudden and they break into small groups, they need to stay in groups where they can still have enough fish where they can have one going to the right. Well, then the other fish next to its tail's got to be going to the left. And it turns out that for different species, what a school is defined by different things. So that's what the next research paper we're going to talk about briefly is. And it talks about schools are not just some arbitrary number of fish. Schools are a very specific grouping of fish, and for some species that may be it has to be 3. For others it has to be 4. But usually it's between 3 and 5, and anything over that becomes a school. And in a school, fish behave differently. They behave differently to danger, they behave differently for spawning or to their own kind, and for searching for food. And they act as a group, which then causes things like hormones, the level of aggression, to all be modulated by things like cortisol and adrenaline and, you know, epinephrine, all sorts of different body chemicals. And so when fish are in a school, there's an actual kind of switch that flicks in their head, that, or in their neurology, their biology, that changes their behavior, that gives them a actual serotonin and dopamine boost of, this is where I need to be. And it comforts them, just like finding shelter comforts them. So a fish out in the open that's a schooling fish is, in a sense, in a state of stress. And it turns out that they can figure this out by actually monitoring the chemicals put off by fish, because they put off stress hormones and chemicals just like humans do. All right, now the last subject of the video is about mormyrids, or elephant nose fish, my favorite. And this is absolutely bonkers insane. What they've figured out is all the things I've already said are true about the tails canceling them out and things like that. But these fish hang out in shoals, and shoals are like a school, but they don't quite look like a completely unique fish. It's more like small groups, a few individuals, and they're all loosely hanging out. And this is what mormyrids tend to do. Now, they do form up into schools, but when they are not under threat, they hang out in shoals. Now, we know mormyrids have the biggest body-to-brain ratio of any animal out there other than primates. Absolutely massive. And the other thing they have is a fascinating body that, if you look at up close, they actually have the ability to create all sorts of electrical impulses, and they have the ability to sense them, which I suppose makes sense, right? But these aren't used for stunning or hunting, stunning other animals or prey or hunting. This is used in a different way, and for a long time it was a big mystery. So pretend, if we look down here for a moment, that this scene here, this is the same scene with the scary danger fish, with the other mormyrid here, and then these two buddies here. This is what it would look like from above. But with cell phone towers, we've made software that says, okay, you've got a bunch of users over here. If there's an emergency, you're going to have all these users here. So with all those signals coming out, all those waves coming out, big signals here, that tells this tower, there is a whole bunch of people that need to get their calls out. This is probably going to go down. So then they allow this tower to pick up a portion of all the phone calls. So no longer are these calls going out all over the place, but this bandwidth of calls, this directional one, is now going to the next tower over. And so this tower then can take anything coming in from that whole area over here, and it can deal with managing that. Now likewise, this tower here is going to deal with everything coming from this direction, and this guy here, everything here. But in that center area, there doesn't need to be as much coverage, and they can allocate which cell tower is on. Now, pretend that the cell towers could move. So if these cell towers were moving, this whole thing would be constantly changing. And the software they created actually models something that a biology student thought, you know what are mormyrids doing with their electric signal, with the magnetic force they're able to create, the electromagnetic force that they can make these signals? They can make sounds, essentially, let's call them sounds, but they're actually electrical pulses that the other fish can sense. And we know there's about 30 different, let's call them words, or different unique pulses that they can say at a time. And we know that some of them are, like one in particular, they'll say, hey, and it's like click, 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 at a certain frequency of electricity. And all of a sudden, everybody in the river that's a mormyrid stops making electrical pulses. And that little specific click means be quiet. And all the other mormyrids are quiet. And then they wait for that same mormyrid that made the noise to talk again, because it meant that he had something really important to say, like, guys, I am being chased by a scary fish right now. Now, we don't know if their language works like that, and we're trying to decipher all this, and we're actually using AI. But what we did find out recently is that this whole system of sensing one another, that the clicks, they're constantly putting out little clicks to feel the world around them. So they're constantly putting out like little just like a bat would, or a dolphin. Say if they want to eat food here, they've got little sounds or electrical pulses they're making that come out in one shape, and then they wait for the time delay it takes to come back for them to hear it. But with electricity rather than just sound waves, there's also a lot of it that goes off into nowhere. So what these fish are able to do, it turns out, is they can keep track of what all the fish around them within, their sensory distance, which we still don't know all the details of. And so this fish can instantly know, at the speed of electricity, at the speed of light, it can know what all the other fish are putting out signals for. And if it hears like, ooh, soft food, it can then focus its mind and its energy and its next clicks over here. So they could cover 3 times more area with that software that in complex math modeled how they would handle that. Well, it turns out that that is the range that mormyrids already work in, rather than the one that we would expect from the intensity of the electric impulses that they put out. We would expect it to be, we're going to say 10 units of distance in every direction with how much energy is put out. But when there are others around, that 10 square units of space distance all of a sudden goes all the way up to 30. So they can see 3 times bigger area, and it's actually, it's exponential too. And when we're talking about surface area, this is actually 3D. So it's not just 3 times, it's actually logarithmic. It's exponentially going up. It's not just, 2-dimensional. So this is absolutely fascinating, and we need to figure out, like, what are they able to talk to one another about? Are they using this as a language? Also, it appears that they are for some things, like at least for saying, hey, there's danger, be quiet. But on these other ones, we realize now that they are passively sensing what all of the other mormyrids, dozens of them, whatever they're doing in the water nearby. And it's like a giant grid with different nodes that are all working together, and they're all sharing information so that they can all swarm in, because they live in very muddy rivers, like in the Nile, for instance, in Africa. So I thought this was absolutely fascinating, and I just had to share it with you guys immediately. We covered it in a live stream quickly, but I just wanted to explain it a little more in full, and I hope that you find it interesting. Read up on it more yourself. I still don't quite get how all of this science works. It's over my head, but maybe someone out there is an electrical engineer or a math major, and you can let me know what I messed up on after you read the paper. I'll put all the details in the video and link below. Thanks. All right, that's it. Content's over. You guys can leave. Go on. You go on to the next video. Oh, but please like and subscribe. It really does help. And if you guys have any thoughts on today's content, boy, would I love to have a conversation in the comments about that. You guys always give me the most interesting topics and send me articles and things like that. And I really couldn't do this channel without you. So thank you so much for your time, for being a part of this community. And again, to you members who pay $1.99 extra a month, you guys are really the lifeblood, the curators, and the producers of the content on this channel. I'm always listening for what you guys are interested in and what you guys want to learn about next, and that really does steer the channel. So thank you so very much for that, and for keeping the lights on in here, for keeping the fish happy and healthy, and allowing me to spend so much time doing this research on what otherwise may not get picked up by really anyone on YouTube. So thank you for being a part of what really doesn't go on in any other nerdy little corner of YouTube. I truly, truly do appreciate it. Have a wonderful day, you guys, and I will see you on the next episode of FISHTORY.